let's look at this lesson. This is 2.5, simplifying and evaluating expressions. So there's basically two types of problems. We're either going to be simplifying, which really means we want to combine any like terms that we can find within an expression. And so I'm going to start with that, and then we'll come back at the end and do some evaluating. So when I talk about simplifying and combining like terms have to have exactly the same variable part. And so that might mean that there's no variable at all, like it's just a number, so numbers can be combined. Or maybe there's an X with that term. And terms are always separated by pluses and minuses. So this is considered one term, this is a different term, this is a different term, this is a different term. See how they're separated by the pluses and minuses? Okay, so like I said, you could have just a number, you could have just an X attached within your term, but having a single X, this is considered an X to the first power here, is different than having an X that's squared. Those are not considered like terms because their variable parts are not identical. So when we are simplifying, we're trying to identify anything that has exactly the same variable parts. Typically, when we write these, we'll always write them with whatever, like when you're looking at your variable terms, whichever variable has the highest power. So I'd probably look at these X squared terms before I'm going to look at the single X terms. And then the number terms are always the last thing that I would try to combine. So I scan through this and I look for all the X squared terms. And I can see there's an X squared term right here and then another one right here. And just think of this as an X squared. You got 6X squareds plus 5 more X squareds is sort of how I say that in my mind when I'm doing it. So how many X squareds would I have? Well, I would have 11. So you just write 11X squared. You don't do anything with that X squared. The variable part doesn't change when you're adding or subtracting these. Okay, now we're going to do it again. And let's find any of these terms that have just an X. So this term here has just an X, and this term here has just an X. So then I look at the coefficients, that number that is in front of the variable. So in this case, it's the -4, and down on the end, it's a 3. What I do is I just combine those coefficients. So the 6 and the 5 on the previous one, that was nice and easy. Now they're going to throw me some negatives. That's okay. We've worked with negatives. So what I have here is a -4 plus 3. Okay, well, that would be a -1. So I'm going to have a -1 x, and I'm going to leave that x or that 1 there, but because some people kind of like to think of that and remember that that's a 1, but recall that really that 1 here is an optional value. If that 1 was not there, we just assume it is. So more often you're going to just see like -x, kind of like just looking ahead. See how it says plus x? I assume there is a 1 here, even though it's not written. So this is optional. It won't get counted wrong if you do write it, but typically as we move forward, this is not going to be there. So I'll try to not write it from here on to get you used to that. All right, and then the last thing would be to combine the number terms. Okay, so I have a +2 right here, and then this is a -6. So I'm thinking of a +2 and a -6 ultimately is what's going on there. And what I end up with is then a -4 out of that. Your final answer should not have any like terms in it because you've already combined all of them. And so none of those variable parts are the same. So I'm done. That is this simplified expression. All right, let's take a look at this next one. What's different on this one is that we have parentheses. And these aren't like parentheses where you're trying to combine anything on the inside because they've already like simplified anything. These are not like terms. They cannot combine. So really what this is showing is this 5 that's in front of here. They don't really show a multiplication symbol, but we assume that anytime there is a 5 in front of a 5, any number is in front of the parentheses like this, that there's assumed to be multiplication right here. This 5, though, is being multiplied by everything in those parentheses. We call this the distributive property. What you're going to do is you're going to take the 5 and you're going to distribute it through the parentheses. And it's going to get multiplied by the 3x, and then it's going to get multiplied by the positive 3 that's there. So what that would look like when you take the 5 times 3x, it's okay to multiply these even though they're not like terms. Now, you can't add and subtract unless they're like terms, but multiplying is okay. You have 5 times 3x. So it's almost like you'd have a 3x written 5 times out that you're trying to combine. There would be 15x. That's what that would look like. 5 times 3x is 15x. And then since there's a plus sign, I'll put a plus, and then I do the distributive property here. So 5 times the 3 is a 15. When I distribute, now the parentheses are no longer there. And then I just finish that out. Now, once the parentheses are gone, I'm back to just combining any like terms that I see. There are no x squared terms, but there's an x term and another x term. Remember that we assume there's a 1 right here. So a 15x plus a 1x would be a 16x. And then the 15 doesn't have any like terms, so we just write it. And there's our final answer. Okay, I have several more of these, a little bit harder, just different things happening throughout. Okay, so on this one, I see the parentheses, and that typically is the first thing that you want to get rid of. So I'm going to take this 2 and I'm going to distribute it to everything that's inside of those parentheses. And then I'll do the same thing with the 3. I'll distribute it to everything inside the parentheses. So I'm going to end up with a 2 times x squared, that's 2x squared, plus 2 times 3x is a 6x. Now, I wish I would have put like a minus sign in here. Maybe I'll have one later on. In fact, maybe I'm just going to change this just so that you see how this plays out. Let's pretend that this, instead of a plus sign, was a minus sign right here. So ignore this little blob, because when you distribute, you would pay attention to that. That's a minus sign. So it's a 2 times a 3. So yes, it's a 6, but it's almost like it's a 2 times a negative 3. Or you're just doing the subtraction. But somehow or the other, that 6 would end up being negative. Okay, let's keep going. Let's go up plus sign, just bringing this straight down. And now I'm going to take this 3 and I'm going to distribute it through. So I'm going to have a 3x squared plus 3x plus, and 3 times 1 is just 3. After you get rid of your parentheses, now you're looking for like terms. The highest exponent that I see is an x squared. So I'm going to combine all the x squared terms. Those are it right there. So I'm going to take a 2 plus a 3. So remember that the variable part does not change, just that coefficient in front of the variable does. So it's a 5x squared. Now I'm looking at the x terms. There's a 6x and there's a 3x. Those are both positive. So a 6x plus a 3x would get me a positive 9x. Okay. And then the last thing, just the number part. So I have a negative 6 plus a 3. A negative 6 and a positive 3 is going to get me a negative 3. No like terms left. There's your answer. Okay. One more here. What's different on this one is that I put a minus sign here instead of that plus. So what that means is when you're distributing, it's not really just the 2. You almost have to think of that as a negative 2 sitting there. Some people like to change this to like a plus a negative and then think of distributing the negative 2. However it works for you, to get that negative to go to everything in the parentheses. That's what's important. That negative affects everything after it. All right, let's see what we end up with when we do this. So I'm going to have a 2x plus a 4. And then I could write a plus, but I can immediately see that I'm going to have a negative 2 times an x, which is going to be a negative 2x. So I don't really want to write plus negative 2x. That looks messy when you have two signs. So instead of writing that as my final answer, instead of a plus and negative, I'm going to change it to a minus 2x. And then I'm going to take the negative 2 times the 5, and that's going to get me a negative 10. So I'm going to write a minus 10. And then I have this plus 5x hanging out here at the end. All right, so now as I look for like terms here, I can see here's an x term, here's another x term, and here's another x term. So I have three like terms to combine. I'm getting kind of lucky here because this 2x and this negative 2x here, those are going to end up canceling each other out. That would just get me a 0x or 0. But I still got the 5x out there. So I have a 5x left. And then when I combine the numbers, I have a positive 4 and a negative 10. I think of that minus sign as just making that negative. And so 4 minus 10 would be a negative 6. Final answer. Okay. I've got one more. Now, I'd like you to try this one on your own and see if you can come up with the right answer. The one trick that I stuck on this one that you're going to come across is, again, I put a minus here, but do you see how there's no number here that's getting distributed? Well, you have to assume that there's like a negative 1 sitting here, and there's the negative 1 that gets distributed because that negative has to go to everything after it. Okay, so I'm going to give you a minute. Why don't you pause the video and see if you can finish this one and then come back and check your answer. But you got to pause the video. All right, did you get 6x plus 12y? I hope you did. A couple things as I worked through it. I realized this is the first time maybe I threw a different variable at you, but it kind of works the same. It's a different term because x's and y's are not the same thing. So you just work with it separately. And then I just really want to emphasize this whole distributing that negative. That's one of the most common mistakes that we see, that people all the time will write minus 4x, but then they do the plus 3y. They don't take that negative all the way through the parentheses. So watch out for that. Okay, so part 2 of this video is evaluating expressions. So not only are we trying to combine like terms, and these examples, the like terms are going to already be combined probably, but what we're really doing is we're saying, okay, what would this whole expression end up equaling out to if we actually had a number to plug in for those variables? So on this first one, what they're telling me here is that x is going to be negative 3. That's what this means over here. X is going to be negative 3. What would this expression end up equaling if I put a negative 3 in place of that x? So what this looks like is 4. And then in place of that x, I'm going to sneak a negative 3 and then squared. And I kind of purposely did this one that's just kind of looks very basic, but plugging in a negative, how does that play out? Well, it's the negative 3 that's being squared. Even if you were trying to use your calculator, which you should not be doing, you have to be careful how these even get entered in a calculator, because a calculator oftentimes will get them wrong. You're taking a negative 3 and you're squaring it. That means you're taking a negative 3 times itself. Negative 3 times another negative 3 is going to be a positive 9. So when you take negative 3 and square it, it's really going to be a positive 9. And 4 times 9 is 36. So that's what that would evaluate to. All right, let's try another one here. Over here on the right, you can see what I'm telling you what the variables are going to be. So x is going to be 4, y is going to be a negative 4. So I'm going to put in place of the x, I'm going to have this negative 6, but instead of an x, I'm going to put a 4. Minus 2, and instead of a y, I'm going to put a negative 4. And then I just have this plus 2 hanging out here. And now I have to go do, it's kind of like you're doing order of operations on this. We are assuming multiplication happening right here and right here. And so we would do those multiplications first. This is really a -6 times a 4. -6 times 4 is a -24. And then this is a -2 times a -4. And that would end up being a positive or a plus 8. And then I got my plus 2 out there. Now what we have left is addition and subtraction, not really subtraction, but we do have a -24. So we're just going to do that left to right, do an order of operations. So I have a -24 plus 8. Well, the negative is bigger, so my answer is going to end up a -16. And then I'd still have my plus 2 out at the side, and -16 plus 2 is a -14 for my answer on that one. All right, this one is my last slide, and just doing a few more evaluating different things that can happen. So I wanted to do one of these where I had that x squared going. So I'm going to go ahead and I'm going to start off by putting the value of a -3 in everywhere that I see an x. So this is going to be -3 squared plus, and then right here, instead of this x, I'm going to put in a -3. You can see they're being multiplied. That's what this is going on in between here, stays that concept right here. And then I have a -6 out at the end. Now we just did earlier, we did this -3 squared. -3 times -3 is a +9. So I'm going to replace that with a +9. And then over here, I'm going to have this 3 times this -3. And that's going to end up getting me a -9. So I could write plus -9, but it would look better just to write -9. And then -6. All right, I still have multiplication going on, so let's go ahead and do that. That's -18. Then I have -9, -6, and I'm just going to do that left to right. I'm kind of out of room, so I'm going to do this -18 -9 would take me to -27. And then -27 minus a 6 would be a -33. So that all ends up being -33 for my final answer. All right, last one here. If you want to pause the video and give this one a shot, you can do that. I am going to go ahead and go through the whole thing, though, as well. First step, I'm going to go plug in the numbers for all their appropriate variables. So I'm going to have a -3 plus, oh, that's kind of weird, plus -7. So there's an example. Plus -7 is the same thing as a -7. I guess write it however you like. And then I'm going to have a -6. And instead of the z, I'm going to put a 3, just using all these evaluation values over here. Okay, so let's work inside of here. -3 plus -7. Or even if it was a -3 minus 7, gets you a -10. So what you want to do here is you want to take a -10 and you want to square it. So that's like a -10 times -10. And a -10 times a -10 is going to be 100. Now over here on the right, I'm going to end up with a -18. So what is 100 minus 18? Well, it's almost a -20, almost 80, but it's a little bit higher than that. It's 82. Final answer. All right. I hope this helps a little bit, seeing some examples worked out. Good luck.